Welcome back to Solar for Math. This is a continuation of partial fractions, episode 4. We want to look at decomposition of algebraic fractions that are improper. We looked at 3 ways and 3 types that we can handle different partial fractions depending on the nature of the denominator of the fraction given. But we looked at proper fractions. Now, how do we handle fractions that are improper? First of all, we need to know what is an improper fraction, an improper algebraic fraction. This is how we define it. We are going to use these questions here, or these fractions here for our study today. How do we identify an improper fraction? An improper fraction, in the normal fractions, we would call a fraction improper if the denominator is smaller than the numerator, like 3 over 2, 5 over 3, 11 over 2. These are improper fractions. Now, if we come to algebraic fractions like these ones here, a fraction is considered improper if the degree of the denominator is smaller than the degree of the numerator, or if the degree of the numerator equals to the degree of the denominator. So there are 2 cases. Let's find out if these 2 cases are here. Look at the degree. The degree is the highest power of the highest power of x in the polynomial given. For example, in the numerator here, the highest power is 3. So the numerator has degree 3. Then the denominator has the highest power 2. So degree 3 in the numerator and then degree 2 in the denominator. So this is already improper because the degree of the numerator is bigger than the degree of the denominator. Let us check this, the second one. The degree in the denominator is 2, as we can see here. What about this? If we expand this, if you try to expand this, you will see that we end up with x squared plus 3x plus a 2. So the highest power of x is a 2. So we see we have the degrees equal. Degree 2 in the numerator, degree 2 in the denominator. This qualifies to be an improper fraction. And this, we have degree 3. And then when we expand this, it also gives us the highest power of x as 3. Because we have this as power 1. When we multiply it with power 2, they will give us power 3. So these 3 qualify to be improper fractions. So how do we handle this? How do we handle this? The procedures are, we first reduce the fraction into 2 parts. One part that may be a whole number. For example, in this case, if I'm to use these numbers, these fractions, 3 over 2 can be expressed in terms of a whole number, then plus a proper fraction, which is 1 over 2. So the same thing we do here. We express these fractions into 2 parts. One that may be a quotient, and then the other part will be a proper fraction, as we're going to see. Then we can go on after finding these 2 parts. We concentrate now on this part, which is a fraction, and reduce it into partial fractions because it is now proper. We can now use the other procedures we looked at before. If you haven't watched them, the videos, you can check in the description below for the links, or you can browse this channel for the videos. Let's see how we handle. Let's start with number 1. How do we decompose this? First of all, we said first examine if it is an improper fraction by studying the degrees of the numerator and the denominator. Here we've already determined that these are improper fractions. So we just need to go and decompose. So we said since they're improper, we have to first decompose them into two parts. One part that is like a whole number, then the other part that is a proper fraction. So how do we do that? We use long division. So what we are dividing goes inside, like the numerator goes inside this. So we have x cubed minus 4x minus 5. Then what divides remains outside. So x squared minus x minus 6. So let us divide. We use the first terms to divide. So let's divide. So I'll get x cubed, the first term in the under the root sign, x cubed, divide by the first term outside the root sign. So x cubed divided by x squared, it gives me x. Now multiply this that you've gotten throughout this and write the answer under here. So x times x squared gives us x squared. X times negative x gives us negative x squared. X times negative 6 gives us negative 6x. Then we subtract. What do we get? When we subtract, this is x cubed minus, this was a cubed. Sorry, this was a cubed because we multiplied x times x squared, we get x cubed. This was a cube. So we have x cubed minus x cubed, it is a 0. We don't have any power of any x power 2 up here, so it's like 0 minus 0. It's like 0 minus this minus, then minus the negative, this negative x squared, and this gives us plus x squared. Now the terms in x, we have negative 4x minus negative 4x minus this minus, then negative 6x, and this gives us 2x plus 2x. Then the terms, the constant terms, we have negative 5 minus a 0 because we don't have any constant term here. It's like we have a 0 here. So minus 0, remain with negative 5. So we go on to divide until when the highest power of the polynomial we get, of the expression we get, is less than. Until when it is less than the highest power of the divisor. So let's move on. They're still the same. So it means we may still have an improper fraction. So we're going to divide. So get this x squared divided by this x squared. What do we get? We get a 1. So plus a 1 here. Multiply the 1 throughout this. We get the same thing. X squared minus x. 1 times negative 6 minus 6. Subtract. What do we get? On subtracting, this will be a 0. Terms in x, we have 2x minus negative x to give us plus 3x. Then we have the constant terms, negative 5 minus negative 6, which gives us a positive 1. Now, since now the highest power here is 1 of x, then here it is 2, it means we cannot go on to divide. So we write our expression. This expression now becomes, this is like now our whole number, our whole expression, x plus 1, then plus our proper fraction, which will be the remainder here, which is 3x plus 1, over the divisor, which is x squared minus x minus 6. Now we go on and decompose this, because it is a proper fraction. Now we go on and decompose it using the procedures we learned about in the previous videos. So let's go on and decompose. So let's decompose this. 3x plus 1 over x squared minus x minus 6. How do we decompose it? First of all, we study the denominator. We said study the denominator, find out its nature. Do we have quadratic factors? Do we have repeated factors? Do we have linear factors? So since it is a quadratic expression, we need to factorize it out so that we find its factors. If you're able to find factors, then we know it has linear factors. If you're not able, then we conclude it has quadratic factors that cannot be, it's a quadratic factor that cannot be factorized. Okay, let's factorize this. So our expression is x squared minus x minus 6. If you had to factorize this, look for two numbers, which when you multiply, you get a negative 6, and when you add them, you get negative 1 here. So our values are 2 and negative 3. So it means this expression now becomes x squared plus 2x minus 3x minus 6. You can review one of my videos on factorization. Okay, so when we group this and this, we group this and this, we get x into, factor out the common factor here in this group, it is x. We remain with x here plus a 2. If we factor out the common factor here, which is minus 3, we remain with x here plus a 2. So the common factor here is x plus 2, and what remain with here, we remain with x minus 3. So it means we are able to factorize this denominator here. So it has linear factors. So this expression becomes 3x plus 1 over x plus 2 into x minus 3. So how do we decompose this? We said if there are linear factors like this, then they take on this form. We expect, of course, two partial fractions with the numerator being numbers. So we assume the numerator will be a for the first fraction over this factor, then plus the other one will also be a number over the other factor. Okay, so we go on and express this with a common denominator, and the common denominator will be a product of the two factors, x plus 2 into x minus 3. So if we divide this by this, we get x minus 3 times a, which is a into x minus 3, plus if we divide this by this, we get a plus 2, x plus 2 times b, which gives us b into x plus 2. So we need to find the values of a and b, and if we are successful at that, we substitute them back here, and then we have our partial fractions. So we relate the numerators. Remember, the numerator here is 3x plus 1. So since the denominators are the same, we can relate the numerators. So it means that 3x plus 1 can be related with a into x minus 3 plus bar into x plus a 2. So we assume values of x that satisfy this. Of course, all values of x satisfy, but we choose intentional values that will help us find these unknowns. So I'll choose values of x that will help me eliminate either a so that I find b, or to eliminate b so that I find a. And I can see that if I take my x to be, if my x is a 3 and I substitute it here, this a will go. So I'll be able to find a b. So substituting in the expression, we have 3 times 3 plus 1 equals 2. This will disappear because we have a into 3 minus 3, which is a 0, plus b into 3 plus 2. And this is 10 equals 2. We say this goes to 0. So this remains 5 bar, which gives us our b as a 2. Let's find a. So to find a, I should find the value of x that will help me eliminate a b, and that would be x equals to negative 2. The additive inverse of 2 is negative 2. So it will make x disappear. I mean b disappear. So when we substitute, we get 3 times negative 2 plus 1 equaling 2. If we substitute 2 here, negative 2 remain with a into negative 2 minus 3 plus this will be a 0. So what remain with here? This will be a negative 6 plus 1 equals 2 negative 5a. So this gives me negative 5 equals negative 5a. So when we divide through by negative 5, our a is a 1. So it means this partial fraction here, the 3x plus 1 over x squared minus x minus 6, will be equal to my a, which is 1 over x plus 2, and my b, which is a 2 over x minus 3. Alright, so once we get this, we substitute it back in the other expression that we initially got. So it means our partial fraction x cubed minus 4x minus 5 out of the x squared minus x minus 6 is equal to the x plus 1 we got after long division plus the 1 over x plus 2 plus 2 over x minus 3. And this is the answer. Remember this one, the 1 over x plus 2 plus 2 over x minus 3 is representing the other improper fraction that we got after long division. Let's look at number 2. Number 2, we already found out that it is an improper fraction because the numerator, the degree of the numerator is equal to the degree of the denominator. So we have to go to long division so that we reduce the fraction to a proper fraction and then a quotient. So what do we get here? Before we go there, we cannot divide with this expression in this form. So we need to get an alternative expression of this, x plus 1 into x plus 2. And this we know by expansion, this will be x squared plus 3x plus 2. So we are going to divide by this. This is our divisor. So by long division, we have our root, and then we have the 2x squared plus 3x plus 1 inside. Then outside we have the x squared plus 3x plus 2. Now let's divide. On dividing, we said divide the first term under the root by the first term outside the root. So 2x squared divided by x squared gives us a 2. 2 times, then multiply this answer, this value, by everything here, so that we subtract here. So 2 times x squared gives us 2x squared. 2 times 3x, it gives us positive 6x. 2 times 2, we get positive 4. And when we subtract here, this gives us a 0. And then 3x minus 6x, we get minus 3x. And a 1 minus a 4, we get a minus 3. So we said once the degree of this value here, this expression here, is less than the degree of this expression, we stop. So it means our fraction now becomes, this expression becomes the 2, which is like our whole number, plus this one, which is negative 3x minus 3 over x squared plus 3x plus 2. So we're going to decompose this expression here. Now that it is proper, we can go and decompose it. But this one, we may even simplify it like this, because if I look at this, it's the same as 2 plus negative 3 is common. So when I bring negative 3 out, I remain with x plus 1. And I already realized that we had this factor in the denominator, which was x plus 1 into x plus 2. And this would give me 2 plus minus 3 if this and this goes over x plus 2. So it means we've gotten a shortcut, and our answer, this in terms of partial fractions, would be a 2 minus 3 over x plus 2. You can go on and use the other procedures, okay? Because we already know that this has a denominator with linear factors. So go on and express it into partial fractions, find a and b, because we expect 2 partial fractions, and see if we end with the same answer. And surely it will be the same answer. Let's check number 3 and the last one for this episode. We already found out that this was an improper fraction, since the degree of the numerator was equal to the degree of the denominator. So we have to go right away into long division, so that we reduce this into a proper fraction that we can decompose. So before we go there, we need to expand this. Let's expand x plus 1 into x squared plus 1. When expand this, we end with x cubed plus x squared plus x plus 1. Kindly take time and expand this. You end up with this expansion. So it means if you are to divide, we go to long division. We have the numerator under the root plus 2x plus x plus 3. And then outside we have this, replacing this, so which is x cubed plus x squared plus x plus a 1. Let us divide. When we divide, x cubed divided by x cubed, we get a 1. 1 times all of this will be x cubed plus x squared plus x plus 1. Subtract, what do we get? If we subtract, we get, this is a 0. This will be 2x squared minus x squared, remain with x squared. X minus x is a 0. Then 3 minus 1, get a 2. So we've remained with x squared plus 2 here. And we said once the degree here is less than the degree here, we stop. Alright, so it means our fraction now becomes the quotient, which is 1 plus the remainder here, which was x squared plus 2 over the divisor, which was x cubed plus x squared plus x plus 1. Now we go forward and use the steps of decomposing partial fractions to decompose this proper fraction. So we have to examine this expression here. Is the denominator having linear factors only? Does it have quadratic factors? Does it have repeated roots of factors? Let's check. We already know what the denominator is, because the denominator is x. We have it here, x plus 1 into x squared plus 1. So we see it as two cases. We have a linear factor, and then we have this as a quadratic factor that cannot be factorized. Because if you try to factorize, or if we try to find the value of x plus 1, if you try to equate this to 0, this will be x squared equals to negative 1. Trying to get the value of x to give us complex roots. So once we find that, your calculator will give you math error here. Once we find this, then it shows that this factor cannot be factorized. So how do we handle? Let's go forward. Alright. So we said this has a linear factor. So we said the linear factor will have a numerator as a, like it's a number, just a number. It may be 1, 2, according to what we find, over the linear factor, which was x plus 1, then plus. Now, the other factor, which is x squared plus 2, has a numerator, which is of the form bx plus c over x squared plus 1. Now, we find a common denominator. We relate this as a common denominator. Common denominator will be a product of these denominators. So when we divide this by this, we get this times a, gives us a into x squared plus 1. Then plus, when we divide this by this, we get x plus 1 times this. So we end up with x plus 1 into bx plus c. Now, since the denominators are the same, we relate the numerators. And if we relate the numerators, we have a into x squared plus 1 plus x plus 1 into bx plus c equaling to this, which was x squared plus 2. Alright, let us find values of a, b, and c. So I will choose is the values of x that can, first of all, if we can find values of x that help us eliminate some unknowns so that we can find the rest, that is the best. So I can see that if I first use x, if my x is equal to -1, I can eliminate all of this factor and I remain with this factor with a. So when we substitute, we have a into -1 squared plus a 1 plus this will be 0 is equal to, this will be -1 squared plus a 2. So this will be a 2a equaling to, this will be a 1 plus 2, which is a 3. So we get our a as 3/2. Okay, let's choose another value of x that can help us find other values. If my x is equal to 0 and I substitute, it means this one will give me a into 0 plus 1 plus, this will be a 0 plus 1 into, this is a 0 plus a c equaling to 0 plus a 2. This is equal to 0 plus 2. So when we simplify, this is a, this will give us a plus, this is 1 times c, which is a c, equaling to a 2. But we have our a as 3/2, so it means c will be 2 minus a 3/2, which gives us a 1/2. Let's go and find our b. I can let my x to be equal to a 1. If my x is 1, on substitution to the expression, I have 1 plus 2 equaling to 2a plus 2 into a b plus c. Now, if we substitute, because we have the values of a and the value of b, we have a 3 here equals to 2 times 3/2. Remember our a was 3/2 plus, this is now 2 times c, but our c was a half, then plus 2b. So this is a 3 equaling to a 3 plus 1 equaling to 2b. So 2b will be equal to, oh sorry, this is a plus 2b. So 2b is equal to a 3 minus 4, which gives a -1, so giving me my b as -1/2. So when we substitute in our expression, if we substitute back here our a and our b, okay, we see that x squared plus 2 over the x plus 1 into x squared plus 2 will be equal to our a, which was 3/2, divided by the x plus 1, then plus our b x, but our b, we've got it as a -1/2 bx plus c, which we got as 1/2 over x squared plus 1. Now this one can be rewritten as 3/2 into x plus 1. Then if you look at this, we have a common factors. We can factor out -1/2, so that we remain with, in the numerator, we remain with x minus 1 over the denominator, which is x squared plus 1. So this is a decomposition of this. So now we take it back to the original expression. So the original expression, which was x squared plus 2x squared plus x plus 3 over x plus 1 into x squared plus 1, is equal to the quotient, which was 1, then plus the partial fractions that we've gotten, which is 3 over 2 into x plus 1 minus x minus 1 over 2 into x squared plus 2. That is it. Don't forget to subscribe, to like, comment, and share this information to anyone that may need it. God bless you.